All right, today we're jumping into a fascinating research paper that tackles a huge problem in our superconnected world. It's called Zync, a microservice platform for IoT device management and complex event monitoring. Basically, it's a new system designed to make sense of the absolute chaos of data coming from all of our smart devices. So this work comes to us from a team of researchers at the University of Cadiz in Spain, and it was published in the journal Computers and Electrical Engineering. What they've built is a full-stack, really practical framework for real-world IoT stuff. Okay, so with that, let's dive right in. Here's our game plan. We're going to start with the big problem Zync is trying to solve. Then we'll get to know the platform itself, pop the hood to see how it works, check out how it performs under pressure, and wrap up by looking at what's next for this kind of tech. Let's be real. Our world is swimming in smart devices. I'm talking everything from tiny environmental sensors out in the ocean to massive industrial monitors keeping factories humming along. And every single one of them is creating this relentless, non-stop tsunami of data. The paper boils this challenge down to three huge hurdles. First, you've got data interoperability. How do you get a sensor from company A to talk to a system built by company B? Then there's scalability. How do you handle data from a whole city's worth of devices without everything just grinding to a halt? And maybe the biggest one, real-time processing. How do you find that one critical event, that needle in the haystack, the second it happens, when every moment counts? So how in the world do you find those critical signals buried in all that noise? Well, this is exactly where the researchers' solution comes in. It's a platform they call Zync. Now, the secret sauce behind Zync is something called complex event processing, or CEP. Honestly, the best way to think about it is like a super smart detective for data streams. It's not just looking at one data point at a time. No, it's looking for patterns, for connections, for sequences of events as they are flying by in real time. And that's the whole point, right? The goal isn't to just collect mountains of data and store it somewhere. It's to turn that raw, messy data into something you can actually do something with, like getting an alert about a potential equipment failure before it shuts down an entire assembly line. All right, let's pop the hood on the Zync engine and see how it actually builds this bridge, from a simple sensor reading all the way to a meaningful alert that pops up right on your screen. So Zync is built on this really clean, modern four-layer architecture. First, you've got the IoT devices layer at the bottom, just sending in raw data. That data flows up to the REST API layer, which is like the front door or the bouncer, checking everything. From there, it goes to the microservices layer. This is the brain of the operation, where all the analysis happens. And finally, everything important gets stored in the database layer. This separation of powers is so key because it's what makes the system flexible and able to grow. Now, one of the things I think is so cool here is just how user-friendly this whole process is. It starts with this, a simple, clean interface where you just add your devices to the platform. No crazy configurations, just a straightforward list of the things you want to keep an eye on. And then comes the really fun part. You get to define what actually matters. You can see here, a user is creating a rule that basically says, hey, send me an alert if the temperature is high and the salinity is low. And look, it's all done with dropdowns and simple logic. You absolutely do not need to be a programmer to tell the system what to look for. And boom, here's the payoff. The second those conditions are met, an instant clear alert gets pushed to the user's phone. It tells you exactly what happened, high temp, low salinity, and where it happened. It's all the critical info you need right at your fingertips. So that all sounds really good in theory. But how does Zync actually hold up when things get crazy and data is flooding in? Well, the researchers ran a bunch of stress tests to find out. To measure performance, they focused on this really important metric called P99 latency. Now, this isn't your typical average speed. P99 tells you about the worst case scenario for almost everybody. It answers the question, okay, when the system is under heavy load, what's the maximum delay that 99 out of 100 people are going to experience? It's a fantastic way to understand how a system really behaves under stress. And you can see exactly what happens here. As you throw more devices at it, the latency, the delay, it starts to climb. But, and this is the important part, even with 50 different devices sending data all at the same time, the delay is still just a few seconds. That's pretty solid. So what does that all boil down to? Well, at its peak, the system was handling almost 7 requests every single second. This proves it can actually manage a continuous, pretty high-frequency stream of data without just falling over, which is, essential for any real-world IoT system. So the results definitely show a promising platform. But one thing I really appreciate about this paper is how honest it is about the current limitations and, the future potential for a system like Zync. On the one hand, you've got these huge strengths. It's fast, and that no-code rule thing is just incredibly user-friendly. But on the other hand, there's for sure room to grow. Right now, the rules are static. They don't learn or adapt over time. And it currently only speaks one language, so to speak, when it comes to taking in data. And this all leads to a much bigger question, doesn't it? What does the next generation of these platforms really need to be able to do to keep up with our world? The authors lay out a super clear roadmap for what's next. Step 1, make the system smarter. Integrate machine learning so it can start finding weird patterns all on its own. Step 2, make it more compatible. Add support for other big IoT protocols like MQTT. And step 3, make it ready for massive scale by building it for cloud platforms like Kubernetes so it can scale up or down automatically. And that brings us to the end of our look at the Zync platform. It's a really powerful example of how to build systems for the Internet of Things that are not just scalable, but practical and, most importantly, usable. The real challenge going forward isn't just about processing all this data, but it's about deciding which events truly matter. As we connect everything, what signals will we choose to listen for?